Welcome back to our Chem 152 video series. We'll be doing problems involving phase diagrams and state changes. This presentation uses content copyrighted by OpenStax. In this question, we are given a phase diagram for water. In this phase diagram, the regions are marked by the state of matter they correspond to. On the left, we have the solid state. In the middle, we have water, the liquid state, and on the bottom, we have the gaseous state. Our question says to start with water at negative 10 degrees Celsius and 101 kilopascals, heat it to 20 Celsius, and then asks, what happens if you perform that operation? First, let's locate the starting point on the graph. The starting point is negative 10 Celsius and 101 kilopascals. 101 kilopascals is roughly 1 atm, or 1 atmosphere. This is about standard atmospheric pressure. The pressure will always be located on the y-axis, and the temperature will always be located on the x-axis. Let's locate 101 kilopascals. It is along this line in the middle. And along that line, we'll also locate negative 10 Celsius. Now, negative 10 Celsius is not labeled, but we do see that 0 is labeled. So we can assume safely that negative 10 Celsius is slightly to the left of that and along the 101 kilopascal line. And this point, which I'll label A, will be our starting point. Now, we are supposed to heat it to 20 Celsius. Anytime we heat up, that means we're going to be moving along the x-axis. Now, heating up moves us to the right along the x-axis. Cooling down would have moved us to the left. Let's look at where we'll end. If we're heating to 20 Celsius, notice that 20 Celsius is also not marked, but we can assume it will be to the right of 0. So we'll move from point A to the right. Notice that we have gone from solid at point A to liquid, which is our green marker. And the process of going from solid to liquid is melting. So you would answer that the process that is being described will be melting. If we had gone the other way, let's say from the green back to the red, that would have been freezing. Again, cooling down something that would have been at the green marker would take us back to the left, changing us from liquid back to solid, which is indeed freezing. Now for another problem. We'll begin this time with water at 100 Celsius and 10 kilopascals. We'll make a mark that represents that. We'll first locate 100 degrees Celsius. We'll follow that 100 Celsius upward, and we're going to make a mark at 10 kilopascals. Now, 10 kilopascals is not labeled, but notice what is labeled is 0.6 and 101, and we know the number 10 will be in between those points somewhere. We don't have to be too exact with this, but it should definitely be in between those points. We'll label that as point B. Now we will increase the pressure to 200 kilopascals. Again, 200 is not marked, but notice that pressure is definitely along the y-axis. And if we are increasing the pressure, notice the pressure goes up as we go up along the y-axis. Therefore, we'll be traveling up from point B. Now, notice the 101 is marked, and we're going to go past 101 and get to 200. That'll be a little bit above the 101. So we'll place our green marker above the 101 at about 200, and then we'll draw our arrow going from red to green. Now notice that we've started as a gas, and we end as liquid. So going from gas to liquid, the name of that process is condensation. If we had gone from liquid to gas, which is the opposite of this arrow, that would have been boiling. Our third problem says to start with water at 0 Celsius and 1,000 kilopascals, and then increase the temperature to 400 Celsius. Once again, we'll make a mark at 0 Celsius and 1,000 kilopascals. Again, 1,000 is not marked, but we know it should be between 101 and 22,089. We'll locate our 0 Celsius. Try to estimate where 1,000 kilopascals would be. As long as we're somewhere in the middle of those marks, that's going to be reasonable, and we'll label that point C. Now we'll increase the temperature to 400 Celsius. Again, when you're increasing the temperature, we're going to move along the X. And we'll be going rightward because that's where the temperatures are getting higher. Now we're going to try to locate 400 degrees Celsius on this graph. The last temperature that's marked, though, is 374. We know 400 will be a little bit higher than that. So we're going to start from our red dot at C. We're going to go to the right. We're going to stop at 400 and put our green marker. Now notice that this green marker is higher temperature than what we've labeled as the critical point. And anytime you're higher than the critical temperature, you are no longer going to become a gas. And what we must realize is if we are higher than the critical temperature, we're not going to stay as a gas. We're going to become something different called a supercritical fluid. A supercritical fluid is a substance that's similar to a gas, but has much higher density. This is because it has some of the properties of a liquid and some of the properties of a gas. Now notice that our red line crosses the boundary between a liquid and a gas at this marker. That marker I've placed an X on shows that we're changing from liquid to gas. So we are boiling. But now that we've crossed this dashed line, indicated by the critical point, anything that is higher temperature than the critical point is going to be a supercritical fluid. So we're going to change at the very end from a gas to a supercritical fluid because our green dot is on the right side of this orange line I've drawn. So to answer this question, we would say this process does boiling first and then shifts into a supercritical fluid. For our final problem, we'll start with water at 0.6 kilopascals and 0 Celsius, and then reduce the pressure to 0.01 kilopascals. We'll place a red marker at 0.6 kilopascals and 0 Celsius at the intersection of these dashed lines and label it D. Then we'll reduce the pressure to 0.01 kilopascals. So if we are reducing the pressure, we're going to go along Y. But if we're reducing pressure, we're going to move down. We'll place our green marker lower on the y-axis, perhaps down in this position, and draw an arrow going from the red to the green. You may notice that we have gone from solid to gas. If you're going from solid to gas, this is called sublimation. If we had started from gas and gone the opposite direction from gas to solid, Usually, in most literature, this is called deposition. So these are all the examples of state change that you can find on a phase diagram. Thank you for watching. We'll see you again soon.